These are the in-class review problems. So this is starting Unit 3 from the problems we did in class. So these questions, I think they were 17, 18, 19, and 20. Probably depends on which class you're in a little bit, though. We want to, which postulate can be used to prove the triangle is congruent? Write a congruent statement. So our 5 postulates we can use are side, side, side. So if we have 3 pairs of congruent sides, then we know our triangles are congruent. Side, angle, side. If we have 2 pairs of congruent sides and an angle, the included angle is also, the pair of included angles are also congruent. We know our triangles are congruent. And then angle, side, angle, and angle, angle, side. And then we have hypotenuse, like. So those are the 5 postulates or theorems that we have to prove triangles congruent. Okay, the first one, we notice we have 1 pair of congruent sides and 1 pair of congruent angles. We need 3 pairs of congruent sides and or angles. Okay, so we want to look for shared sides or vertical angles. We notice here we have shared sides. So AC is congruent to AC by the reflexive property. Okay, so now we have 3 pairs of congruent sides. We go ahead and see which one of our postulates is going to work. Well, this is a side. This is an angle, side. Okay, so we have side, angle, side. Okay, we have side, angle, side. Then we want to write a triangle congruent statement. So we want to name the first triangle. We can name it however we want. Let's name it ADC. Okay, there's 6 different ways to name it. It doesn't matter how you name it. What matters is that you match it up with the corresponding vertex of the other triangle. So which vertex corresponds with A? It's going to be C. Which vertex corresponds with D? It's going to be B. Okay, and which vertex corresponds with C? That's going to be A. If we draw it out, we have to imagine rotating the top triangle here. So we rotate the top triangle. Okay, we end up with A down here, B down here, and C up here. So AC, A, B. So what corresponds with A? C. D, B. C, A. So in triangle ADC is congruent to triangle CBA. I don't know if it's easier to rotate it in your mind and keep it here or flip it and draw it separately, but however you want to do it, that's fine. As long as you get the right answer, it doesn't matter. Okay, we can name this triangle 6 different ways. So we can name it DAC. Triangle DAC would be congruent to triangle BCA. Triangle CAD would be congruent to triangle ACB. Right? Or CAD is congruent to ACB. Okay. 6 different ways to name the first one. Name the second one in the same. This is a triangle. Triangle CBA. Right, number 18, we have a midpoint. Z is the midpoint of YW. So this is YW or WY. Okay. This should be a segment. So since Z is the midpoint, we're splitting it in half. We're splitting in 2 congruent segments. So we know WZ is congruent to ZY. We now have 2. We started with 1 pair of corresponding parts. We now have 2 pairs of corresponding parts that are congruent. We can use the reflexive property because we have a shared side. Right, on these problems, we want to look for shared sides or vertical angles. We have shared sides. Okay, so now we have 3 corresponding parts that are congruent, and we're going to have side, side, side. So by the side, side postulate, we know that those 2 triangles are congruent. Okay, went to a little bit more in detail in class. Try to keep the videos shorter. I'm going to try to go a little faster. Okay, but email me or ask questions if you need to. All right. Triangle congruent statement. So let's name the first triangle WZX. In 6 different ways to name the triangle. So what corresponds with W? That's going to be Y. It's between the 1 and the 2. Y is between the 1 and the 2. Okay. Then we went to Z. What corresponds with Z? Z is between the 1 and the 3. Z is also here going to be between 1 and 3. So Z is going to correspond with Z. And then X is going to correspond with X. Again, if we want to redraw it, so you'd have to flip it over. Like think of this as like a page and you have to flip it over. Okay, so if we flip it over, Y is going to come on top. Z and X are, if we flip it over, Y is going to stay on top. Z and X are going to stay on the bottom. So WZX is congruent to YZX. We can name it. If we name the first one ZXW, then the second one has to be ZXY. 2 triangles need to be congruent. So let's do this. So 19 and 20. All right. First thing we notice is we have 2 pairs of congruent angles, 2 pairs of corresponding angles that are congruent. And then here's your other one. This picture isn't drawn really well, but we can make do. We look for shared sides of vertical angles. We have shared sides, so EC is congruent to EC. We now have 3 corresponding parts that are congruent, 2 angles and 2 pairs of angles and 1 pair of sides. So this is an angle, and this is a side. So we have angle, angle, side. And I don't like this one because it's not drawn properly, so it looks it makes it more confusing than it should be. So if we name one of the triangles, let's name it EDC. What corresponds with E? Well, it's going to be E. Corresponds with D, that's going to be B. And what corresponds with C, it's going to be C. So if we took B and we folded it over on top of D, these 2 triangles would look the same. All right, if we flipped it over, we would have C, B, E. So E and E, D and B, and then C and C. Triangle EDC is congruent to triangle EBC. I don't like that one just based on how it looks. They're telling us in this one we have, they're giving us that angle T and angle Q are congruent. So we have 1 pair of angles. We know TR is congruent to QR. We also have vertical angles. So we have angle, side, angle, angle, side, angle. Okay. Angle, side, angle. We can name the first triangle however we want. Let's just name it STR. What corresponds with S? That's going to be U. So instead of STR, we have UQR. STR. It's going to be congruent to UQR. UQR. R TS would be congruent to RQU. RST would be congruent to RUQ. Okay, so we can name the first one however we want, as long as the second one is in the correct order. Let me see the top here. Okay, it's asking us what additional information is needed to prove the triangles are congruent using the angle-side theorem. So we're using the angle-side theorem. Okay, so got cut off a little. That's B, that's A, that's M, O. So what additional information do we need? All right, let's start with what we have. So we have that one pair of angles is congruent. We have that angle. So what we're trying to prove by angle-side. Okay, we have that angle OBA is congruent to angle MBA. And we have that BA is congruent to BA. Okay, so we have one pair of corresponding angles that are congruent and one pair of corresponding sides that's congruent. So if we have one pair of angles, one pair of sides, the other one we're going to need is another angle. Okay, that gives us two options. That gives us angle O and angle M, or it gives us angle OAB and MAB. Okay, let's just assume it was OAB and MAB. This would give us side angle, or sorry, angle side angle. Okay, this would give us angle side angle. We're not looking for angle side angle. We're looking for angle side. Okay. So it's going to have to be angle O and angle M. And that gives us our last angle. So we have angle side. The side is not included. It's it's not between the two angles. Side cannot be between the two angles. Okay, so the additional information that we need, we're given two pieces. We're given this and this. We're given that angle OBA is congruent to angle MBA. We're given that BA is congruent to BA. What additional information do we need for angle side to work? We would need to know that angle O is congruent to angle M. Triangle ABC is congruent to triangle DEF. Okay, we've done this about 1,000,000 times. So AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. Okay. And if we need to draw it out, we can draw it out. AB, as long as you draw it out in the same order you drew it out the other time. AB, ED. So do I have that? So angles, we have angle A is going to be congruent to angle D. Angle B is congruent to angle E. Okay, and then angle C is congruent to angle F.
I did not forget late. I thought I was asking there someday to find out.
Hey.
Yeah, I'll go on stage.
So this is 21 and 22. So 21, we start with a linear pair. Okay, so we're going to do 180 minus 120 is 60. Always get flustered when they come in. Okay, social skills are not the best. 180 minus 120 is 60. So we have a linear pair. Okay, then we have an isosceles triangle. So we know in an isosceles triangle, the base angles are going to be equal. So since these two are equal, we can do it two ways. Okay, the first way, again, I don't know whichever way your method you're comfortable with. We know 180 minus 60 is 120. So these two angles have to add up to 120. Since it's isosceles, we know they're the same. So all we have to do is divide by 2, and that's going to give us 60 and 60. Okay. The other way you can do it, if you're not comfortable with that, is we can put in a variable. We can say y and y. We know y plus 60 equals 180. Three angles of a triangle add up to 180. So we have 2y plus 60. Subtract 60. 2y equals 180 or 120. And then divide by 2, and we get y equals 60. So either way, whatever you're comfortable with, we're going to get 60 and 60. And because it's an isosceles triangle, it actually ends up being an equilateral triangle or equal angular triangle because all the angles are the same, and equilateral because all the sides are going to be the same. So this is, we have vertical angles. We know vertical angles are congruent, meaning their angle measures are the same, so that's 60. Again, this one we have an isosceles triangle. We know since these two sides are the same, it's isosceles, and we know in isosceles triangles, the base angles are the same. Okay, so that's also going to be 60. And then here we have vertical angles. Vertical angles are congruent, so they're going to be the same. So x is going to be equal to 60. The next one, we start with a linear pair. They're giving us 148. We have a linear pair. So 180 minus 148 gives us 32. Right? Linear pairs are supplementary, adjacent and supplementary. Adjacent because they're next to each other, supplementary meaning they angle measures add up to 180. So 180 minus 148 gives us 32. Here we have a right angle. We know right angles are 90 degrees. So 90 minus 32 is going to give us 58. 90 minus 32 is 58. We have an isosceles triangle. We know the base angles of isosceles triangles are the same. So this one is also going to be 58. And then here we have a linear pair. So x plus 58 is going to be 180. So 180 minus 58 gives us 120. So we want to find all the angles here. All the angles here. So we can start with angle 2. And we can start a lot of different places, but let's start here. So we have 135 and angle 2. We know those are a linear pair. So we can do 180 minus 135 is going to give us 45. So the measure of angle 2 is 45 degrees. We can do the three angles of a triangle add up to 180, or we can do the exterior angle is going to equal the two remote interior angles added together. So the measure of angle 1 is going to equal 60 plus 45, which is going to be 105. Okay, here we had the measure of angle 2 was 105. The other way we could have done this is the three angles of a triangle. So 180 minus 60 minus 45 is going to give us 75. Okay. And then here we have a linear pair. 180 minus 75 is going to be 105. So either way, we're going to get the same answer, 105. Okay. Here we have vertical angles. So this is 45. Vertical angles are congruent. Here we also have vertical angles. So this is 72. Then the measure of angle 3 plus 45 plus 72 is going to equal 180. (45) and 72 is going to give us 117. Right, 70 plus 40 is 110. 5 plus 2 is 7. 110 plus 7 is 117. 180. Subtract 117. The measure of angle 3 is 63 degrees. We have a linear pair. The measure of angle 4 plus 72 equals 180. Linear pairs are supplementary, so their angle measures add up to 180. Subtract 72. The measure of angle 4 is 108. Here again, we have two different ways to do it. We know the exterior angle is 140, so the exterior angle is going to equal the remote two interior angles added together, so 72 plus the measure of angle 5. Subtract 72. Okay, 68 is going to equal the measure of angle 5. The other way we could have done it was linear pair. 180 minus 140 equals 40. Okay. 72 plus 40 plus the measure of angle 3 equals 180. And that's going to give us 112. Plus the measure of angle 3 is 180. Subtract 112. Well, this is 5. I'm sorry. The measure of angle 5 equals 68, which is what we got before. Okay. And that's the Unit 3 questions we had from the in-class review.